Today, we will study about the quadratic function, how you convert from standard form to vertex form by completing the square. I will give you 3 examples. First one, y equal to x squared plus 14x minus 38, which is a leading coefficient is 1. Then first, y equal to x squared plus 14x for x squared term and x term. Up to that, you write, and then you put the space by adding c. I will put the parentheses there, and let's write negative 38 there. Let's decide it when you have to add to make perfect square inside the parentheses. Then you have to think x term here, which is positive 14. Positive 14 divided by 2. Half of that to the square will go to here, which is 7 square, which means 49. There will be 49 here. Then since you add 49, you have to subtract 49 to make a even, like a exact same thing with the previous one. And then we will go back to, if you have a parenthesis shapes like a x squared plus 14x plus 49, then you can make a perfect square as a x squared square root will be x, and then 49, it was a 7 to the square, so plus a 7 to the square. That's how you change it to the perfect square. And then negative 38 minus 49 will be negative 87. So y equal to x plus 7 to the square minus 87 is a vertex form from standard form, and vertex from there you can find the vertex as a opposite sign for this one, which is negative 7 and negative 87. That's a vertex. And additionally, if you try to find the axis of symmetry, because quadratic function is a symmetrical functions, so always you need to find the axis of symmetry. Axis of symmetry happens for the vertex x value, so x equal to negative 7, and this graph a value is a 1, which is a greater than 0, so it's open upward, will have a minimum value. So minimum will be the vertex y value. It's a negative 87. And now, if you have a leading coefficient other than 1, which is a 3 for this time here, then we are trying to make it as a vertex form. First, y equal to, take the 3 factor out for these two terms, x squared term and x term. Let's try to factor out for 3 and x squared plus 2x. And I will leave a little space here because I need to add something to make a perfect square. And then that negative 11, you have to write here, negative 11. Because I didn't factor out for the negative 11, so you can just keep it outside without changing anything. And we need to find what you have to add. If you add something here, that means you have to subtract exactly same thing. But remember, this one has a leading coefficient as a 3. So you cannot simply subtract the inside the parenthesis value. You have to multiply these two value. That's what you have to subtract to make a same as a before. So half of the x term, which is a 2 over 2 to the square, which makes 1 to the square, which is 1, will go here. So I'm going to write down 1 here. But when you subtract, you need to multiply 3 times of 1. That's how you do. And then if you rewrite y equal to 3, inside the parentheses here, if you want to make a perfect square, x plus 1 to the square. And if you simplify this one, this is a negative 11 minus 3. So it's a negative 14. And the vertex from this one will be negative 1. You always write as opposite inside the parentheses as a vertex. And then y value will be negative 14. Same. And axis of symmetry will be x value for vertex. So x equal to negative 1. And then this graph, a value is a 3. So which is greater than 0. It will open upward. So this function has a minimum. Minimum happens in a vertex for y value. So I will say minimum as a negative 14. And then the last one has a leading coefficient as a negative 5, which is a value as a negative 5. So still, whenever you try to change it to the vertex form, you have to factor negative 5 out from x squared term and x term. You don't have to take negative 5 out from the constant term. So constant term, leave it at outside the parentheses. We only take the negative 5 out from x squared term and x term. So negative 5 with the x squared. Since you take the negative 5 out, the inside parenthesis value will change its sign. So negative 6x. And I will leave a little space here to make a perfect square. And then that negative 14 will leave negative 14 here. And since you add something, remember you have to subtract exactly the same value. But because of the leading coefficient, you have to remember these two multiply factors should be subtracted to make an even. And then half of the x term, which is a negative 6 over 2 to the square will be negative 3 to the square, which is a 9. You have to add a 9 here. That means you cannot subtract 9 simply because leading coefficient of negative 5. So I will multiply by negative 5 with a 9. That's when you have to subtract. And if I rewrite this one, negative 5 with inside x squared minus 6x plus 9, you can write as a x minus 3 to the square, perfect square, and negative 14 minus negative 45 makes positive 31. So the vertex from here will be opposite sign 3 and then same sign 31. That's a vertex. And a value is a negative 5, which is less than 0. Then the graph is open downward, will have a maximum. So axis of symmetry, x value for the vertex, which is a x equal to 3. And this graph, since it's open downward, will have a maximum as a y value for the vertex, which is 31. And remember, all quadratic function domain will be always all real number, which is negative infinity to infinity. If I try to express what is a range, I will do this. Range for the first functions here will be, since this graph has a minimum as a negative 87, so minimum start from minimum negative 87 included to the infinity. That's a range. And then second function's range will be, since the graph has a minimum as a negative 14, I can start from the negative 14 to the infinity. That's a range. And the third the last function will have a value as a negative, so it's open downward, which is a maximum. So the range for the last one will be starting from negative infinity to 31 as a maximum included. That's what I do.